Hey guys, this is video 1.4. We're going to talk about separation techniques, various techniques that we will use throughout the year in different capacities that allow us to separate matter. Okay, so let's just jump right in. Kind of a little bit more definition stuff. I know it's not the most exciting. Make sure you are familiar though, because these will pop up on that Regents exam. You know, at least one question about one of these four techniques. So some are pretty obvious. You probably have background information or experience with. Some might be new. So here we go. Filtration. First one, kind of pretty common. You probably know this. Do you think this is a physical or chemical separation of matter? This is a physical separation. So basically, guys, to describe it, filtrate, okay, which is the stuff that's all mixed together, flows through paper, okay, undissolved particles, i.e. solids, remain on the filter paper. Okay, so what types of matter will it separate? Big one here you got to think of is heterogeneous mixtures. Okay, or mixtures involving more than one phase. So something like sand and water. Okay, which technically would be considered heterogeneous, but just kind of drive it home there as well. All right, next one. We have these things called evaporation techniques. Now there's two of them. We'll probably do we'll use at least one of these, if not both of these, at some point throughout the year. You can either use what's called a watch glass, which, like it says, is something that allows you to watch through the glass. And then there's this thing called a crucible evaporation. Either way, guys, you're evaporating off liquid. Okay, so you might think, hey, this is a physical separation. So a description of it, you have separate solute. Now that term solute is something we're going to come back to later on in the year. Okay, I'm not separate. Separate is what we're trying to do. We're trying to separate the solute, which is going to be your dissolved solid. So if I'm using terms here that you're not familiar with, you may want to look them up. Okay, there's terms that are going to come throughout the year. It's good to get a jump start on some of that vocab now. So we're going to separate the solute from the solvent, which is the liquid. All right, by boiling the solution. Okay, the solute the solvent escapes, okay, and the solute remains. This is a very, very limited precision, okay? This is very crude, meaning you're not going to be able to analyze necessarily how much is left or gone other than mass. You're not going to be able to keep it, okay? So your precision is very, very limited. What this is good for, though, is a homogeneous solution where you can recover what has been dissolved. Homogeneous mixture, excuse me, which is also known as a solution, okay? Moving on. All right, now these next two, they might be newer that you haven't talked about or heard about or as familiar about with. Distillation, this might be one that you're familiar with, like a distillery, okay, where they distill different things. So this is another physical separation, all right, where you separate, it's very similar to the last one we talked about. You're separating the solute from the solvent by boiling the solution and recondensing the receiving flask. All this terminology, right? Don't get lost in it. Okay, I'm going to explain it here in just a second. Here's the big difference. Both the solute and the solvent are captured, meaning you keep both of those. The last technique, evaporation, guys, the solvent was gone. Okay, it just evaporated off. Here we're keeping that. Okay, so we're keeping both pieces. So basically, how distillation differs from evaporation, okay, is that this is all an enclosed system. Okay, so I'm going to write that in here, closed system, and I'm going to go back to the previous page. This is an open system. Okay, that's a big difference there. I ran out of space in mine. Hopefully you still have some space in this box. So I'm going to kind of just make it a box, guys. This part still goes with the description. This is used to separate two or more liquids, oftentimes, okay, with different boiling points. Best example, guys, of distillation is if you're ever driving out in Greece along 390. You see those big towers out by the Kodak facility. Those are distillation towers. They have crude substances that they bring in from other companies, and they can actually purify them using those towers. This is used to separate a homogeneous mixture. Also, best example, used to remove impurities from water. Okay. The last technique we're going to talk about, we will see this at some point. I'll do a demo of this for you guys when we get a little bit later in the year. This is another physical means. This is called chromatography. Okay, chromatography. This is going to separate particles based on three factors. 1, size. 2, solubility. I cannot spell. Stability. And 3, polarity. So again, things and terms that we will talk about later on this year. So we're going to see this in different applications throughout the year. Another example of a homogeneous. So you notice a lot of these techniques are used to separate homogeneous mixtures. Well, those tend to be the most difficult. You guys might think, well, filtering is easy, right? Because, yeah, if I have one thing that's a solid and one that's a liquid, that's easy to separate. But if they're all in the same liquid and they're all mixed together, it's a little bit more challenging. Okay, so we've talked about really physical separations here. On the other hand, chemical separations require reacting a sample with something else in order to turn it into a completely different compound. So we'll talk more about reactions again when we do our whole unit on reactions later in the year, but this is kind of a basic point to kind of get started, to kind of introduce you guys to some of that. So you guys can work on practice 4, read the scenarios, and try to identify what technique would be best. See you next time.